Here's some good news. If you understand exponential growth, you'll very easily understand exponential decay. The only difference between growth and decay is that growth is when the value is getting larger and decay is when the value is getting smaller. Exponential decay happens when a quantity decreases by the same factor over equal intervals of time. The values are the same. Y is the final amount. A is the initial amount. R is the decay rate. And hopefully you are adding without being told that it must be a decimal. And T is the time in years. Same thing, only when you're talking about growth, the value inside the parentheses is greater than 1. For exponential decay, the value inside the parentheses is less than 1, because when you multiply by a value greater than 1, the value gets larger. When you multiply by a value less than 1, the value gets smaller. So example 1, determine whether it's exponential growth, exponential decay, or neither. So we're looking for, is the value getting smaller by the same factor? Is it getting larger by the same factor? Or is it not a growth at all, or a decay, or an exponential? So this one is times 1/3. And I'm writing it as multiplication because that's how we write growth factors. So since the values are getting smaller and it has this common factor, then it is exponential decay. I'm just going to abbreviate because I don't have a lot of space. This is, well, that's linear. So I will write, based on the directions, neither, because the directions don't say linear is not an option. If you wanted to say linear, you could, but really you should write neither because that's what the directions tell you to write. And this is times 2. So since it's a common factor, and since it's getting larger, it's exponential growth. This function right here represents the population of a town after T years. By what percent does the population decrease? Now we know it's decreasing because the value inside the parentheses is less than 1. So if 1 minus R equals 0.94, then R must be 0.06, which as a percent is 6%. So it's decreasing 6% every year. This function represents the area in square miles of a coral reef after T years. By what percent does the area of the coral reef decrease? So 1 minus R represents 9/10. So R is 1/10, which is 10%. So it's decreasing 10% every year. Last example, the value of a car is $21,500. That would be our initial amount. It loses 12%. That would be our rate every year. Let's write a function. So the formula is y equals a times 1 minus r to the t. So we plug in what we know. A is 21,500. R is 12%. So let's just simplify that a little. Y equals 21,500 times 0.88 to the t. Graph the function first, then we're going to use the graph to estimate a specific value. So in order to graph, we need a chart. So let's make t, and we'll do y. So 0, 1, 2, 3, 4. All right, pause the video and plug in your values of t. All right, those are my values. I just now have to figure out what scale I can use. And since it's a decreasing graph, I can't make a break. So I have to really think about what I can fit on my graph. It looks like I could go by 2000s, and then I'd fit everything on here. That would be... Yeah, so that would be about 22,000 right there. So, yeah, maybe I could go by like 1,500 or something, but good enough. So, I did the best I could. It looked really linear, but I knew I needed to make it curve and make it kind of hit that asymptote of the t-axis. So I made a curve. We have to now use my terrible looking graph to estimate what it would be at 6 years. So at 6 years, I'll go up to the graph. That's about here. I would estimate $8,000. So my estimate is $8,000 at 6 years. Okay, now, how do you find the exact value? Well, you plug 6 in for t into the equation. So if the equation is y equals 21,500 times 0.88 to the t, I'll plug in 6 for t and now calculate what I get. So I plugged in, I got $9,984.69, so it probably would actually be closer to here. So while that wasn't really that far off, it certainly was over almost $2,000 off, which is why if you have a chance, you should always use the formula, but the question asked me to use the graph, so I used my graph. If you have any questions, write them down and ask me when you come to class.